Good morning. Before I begin, I need to thank the people in the booth for making it possible for me to communicate with you and for everyone here to communicate with me because I'm not bilingual. So sincerely thank you for the work you are doing. And at the end of the day, climate change is a human process. For us to actually address climate change, we need to learn to communicate. So I would like to begin by asking you, how many of you are comfortable speaking with the people you know or work with about climate change? Raise your hand. You're already comfortable. Okay, so maybe 25% of people, keep your hands up. How many of the people you work with are comfortable talking about climate change? And just lower your hand if not. So what I find is that in the United States, the people who are working in climate and are doing emergency management and helping communities adapt, they can understand climate, but then the person they work with thinks about the world differently. They don't think about climate change. That presents us a problem that we have to solve. So today, I'm not going to teach you everything about climate change. I'm going to make a case to you that it is your job to become climate literate and use that knowledge and skills of communicating to do your job better, because we have to do it. It's our responsibility together. It's not just the young people's responsibility, and it's not the old people's responsibility. This is an intergenerational problem. Forever, from now on. This is part of our culture that we will share, that we are building ability to talk, create new stories, and a new way of living on this beautiful planet. Next slide, please. So I will talk about climate literacy. And just understand, when I'm talking about climate literacy, this isn't a bunch of facts. Yes, those are important, but those are just part of your language. There's also the cultural part. There's also the understanding, where is the person you're talking to coming from? What do they care about? So that's what climate literacy means to me. Then I'll go through some of what we know, what we've observed, and what we anticipate with climate change, and why that makes it important for us to adapt. Because the world that your grandparents grew up in is not the world that your grandchildren will grow up in. And so we have to build these skills together. And how we do that is what I work on every day, the steps to resilience. And so I'll tell you a bit about that. Next slide, please. And I was going to begin my talk today with an anthropological story of the rise of hominids, but we saw that story yesterday, and many of you missed a wonderful presentation about humans moving out of Africa. But what I would like to say is that obviously you all know, being here, that the cataclysmic event that caused the last great mass extinction happened right here. This place is also so important in the formation of the Americas. The tectonic history of the Central America and the connection between South America and North America and the formation of the Caribbean is a fascinating geological story. And we're involved now in a story that we are shaping. As biological organisms, we are shaping the way the planet will continue to evolve. And that is very important to begin to grapple with, understand, work with. It's a new skill we have to develop, because we evolved in small communities, 100 people, maybe. And those 100 people that you knew, that your ancestors knew, were their whole life. Now we are connected around the whole planet. And here I am talking to you through technology, through two beautiful people helping me speak to you. And we have to evolve new ways of adapting and understanding. So climate literacy is one of the key components of how we will evolve in every endeavor we do: art, science, politics, whatever business you go into, what have you. Climate literacy is important. Next slide, please. So we have a number of principles that my agency, the National Oceanic and Atmospheric Administration, published just this week. This is brand new. It's an update from, I think, 14 years ago. These principles I'm about to tell you, so this is hot off the press. Next slide, please. The first principle is that climate change is based on observations, models, theory, and a weight of evidence. We know about climate change through the process of science. Now, for people who do not work in science, how many of you are studying science? Not many, okay. A few, good, all right. So those people who do not study science may not have a cultural appreciation of how science works. But those of you who work, say, in fishing or in the real world understand observation and responding to observation. In science, we make an observation, generate an idea, and test it. And that's how we know about climate change and what to expect. So I will be going through some of the evidence that we have. Next slide, please. Well, raise your hand if you know what a greenhouse gas is. Okay, some people do not know what a greenhouse gas is. That is fantastic. Okay, this is an opportunity to learn something important. Our atmosphere is part of what allowed our biosphere to evolve. When I say the word atmosphere, you know what I'm talking about? The air, the movement of the clouds. The atmosphere has gas in it. And those gases themselves, the molecules in the gases, move around, and the movement will release photons of energy, and that is part of the heat we feel when we walk outside. The greenhouse gases are gases that can take a photon from the sun, absorb that photon, change their chemical structure temporarily, and then move faster, and that creates heat. And these greenhouse gases are things that we're emitting. The ones we're concerned about are the ones that we're putting in the atmosphere that create more heat because they are species of gases, molecules, that were not in the atmosphere in the same concentrations prehistorically. So the idea of greenhouse gases is very important to climate change. Next slide, please. So we are putting greenhouse gases in the atmosphere through industrial processes and transportation, heating your home. It's just a fact. This is based on what century was the idea of greenhouse gases warming the planet proposed? What century? Anyone want to? This is the 21st century. The 20th century has just closed. It was in the 19th century that scientists posited that greenhouse gases would warm the planet. And their predictions were pretty darn close to what we're actually seeing. So we've known about this. Science has told us about climate change for more than 150 years. And actually, women scientists contributed very important theory and observations to us understanding our role in shaping the atmosphere. Next slide. In a natural greenhouse world, we would see warming of the planet. Without the greenhouse effect, the planet would be much colder, and we would not have evolved with the body shape that we have. because we would have had to evolve to deal with a colder planet. So the greenhouse effect is an important part of life on Earth. An enhanced greenhouse effect leads to excessive warming that affects all of life. So, basic idea, we're emitting these gases and it's affecting life on Earth across the board, everywhere, in every ecosystem. You live in the tropics, and those effects are very different than at high latitudes. I live sometimes in Vermont. Do you know where Vermont is? Vermont, the Green Mountains. This is very far north in the United States. And climate change is much faster there than here. It's more severe, people notice it. It used to snow every winter and stay snowy. It's not like that anymore. So the things that people feel and experience in different places are different. So when you hear someone say, well, where is climate change? It's snowing. You should know, the climate system is still going to behave the way the climate system behaves on planet Earth. It's just being forced in a certain direction. And so at higher latitudes, we're seeing faster changes due to the greenhouse effect. Next slide. This is something you know about very well. So who has ever gone snorkeling in the room? Okay. Who has never seen a coral reef? Okay. Ever, never seen. Okay. Okay, so this, when you go under the ocean, you discover a whole nother world. Most of our planet, most of us will never see. But when you go in the ocean today, you're experiencing an ecosystem that is under severe stress. And it is the ocean biologists who've been telling us for 40 years that climate change is a severe problem. So this forum, focusing on ocean science and climate change, is part of 4 decades of passionate work to get us all to listen, because the ocean is changing. And this is, you know, the idea of a canary in a coal mine. This is a story that we've been witnessing my whole life. And by the time I went in scuba gear for the first time, it was already pretty severely happening. It's important to go witness these ecosystems. You live right here. If you get a chance, go. If you get a chance, it's worth it. Next slide. In my country, we have a history of injustice that we need to be more comfortable talking about, understanding, and dealing with. Because the people in my country, there are whole groups of people that we've had genocide on, the indigenous people. And bringing Africans against their will to the continent of North America also has created an injustice that's part of our history. And it's a struggle in my culture to accept this reality. It's a struggle. But the young people in my country are telling my generation, we are not doing anything about climate change until you respect people who've been affected, until you learn. We're not doing any of it. So it's almost like they want the whole culture to move. And so for the first time in our climate literacy, we're understanding that in fact we have to work with people. Science is not done just in a test tube. The people are who are going to help solve the problem, so we must work with people to build understanding. And that's why environmental justice is central to the conservation of biological diversity, protecting our climate system, and building the world we want to live in together. Next slide, please. So there are ways of changing our living systems, where we live, how we drive, how we get to work, and what we do. But make no mistake, all of us are building new careers, new ways of living, based on the old, with respect to the way traditions brought us here, and evolving new ways of doing our work. And I will talk more about that. That's what I focus on mostly. Next slide. So, who has not heard the idea of net zero? Is there anyone? Okay, so some people have not heard this term net zero, and what it means is there's been a long-term effort by scientists to get the world to agree that we must reduce our emissions from industrial activity, transportation, our houses, everything in our lives, so that between taking up carbon dioxide where we can and storing it and reducing emissions, the net effect is no more emissions. By 2050, that might as well be tomorrow. To get to net zero, please take this message, is urgent. This cannot wait. And so working with your friends to make sure they're riding their bicycle using public transportation, conserving energy, shifting how we use energy is truly important. That is a central idea to adaptation, because we can adapt to a changing climate, but we also must prevent the most catastrophic effects of climate change that will affect our children and grandchildren. We must. It's our responsibility to give them a world as beautiful as the one we live in. So the idea of net zero was an idea that's been floating around my whole adult life. So when I was in college, it was 1991 was the first IPCC, Intergovernmental Panel on Climate Change. And the international community of climate scientists told us all that climate change is happening, and that to prevent it, we need to reduce greenhouse gas emissions. The message hasn't changed, ever. The science hasn't fundamentally changed. There have been advances, our ability to observe, to model, to make better predictions. Yes, those are advancing, but the fundamental idea that in a warmer world you get more extreme precipitation, more heat waves, and more danger to people, loss of biodiversity, and livelihoods of future generations will be impacted. That has always been true in climate science. Please understand, this message being so consistent is very important, because most of the issue of dealing with climate change now falls on the shoulders, you said, you're not scientists, falls on all our shoulders. It's not for scientists to solve climate change, it is political and social. We must figure this out together. Next slide. So, we must pursue transformational action. And so when I spoke about incorporating environmental justice, when I speak about addressing biological diversity, loss of biological diversity, dealing with the climate crisis, advancing the livelihoods of people who've been underserved, all of that goes together in the idea of transformative change that we are all part of in the future if we want to address the climate crisis. Next slide. So, those are the principles of climate literacy, and you can go on the NOAA.gov website and see and download and use those principles in your learning, in your teaching, in your advocacy, in your daily work. Now, just going back to that first question I asked you, how many of your friends and colleagues are comfortable with climate science, talking about it, understanding it, and using what we know? The fact that they are not comfortable with it means we do have a responsibility to learn a bit more. So I'm going to spend a few minutes reviewing what we've observed just last year. I'm going to focus mostly just what we observed last year in the climate system. I'll focus a lot on North America, where I am from. Well, you're in North America, but in the continental United States, because that's my agency's responsibility, is to focus on the continental United States. I don't work internationally very much, but that is a very important component of adapting to climate change. So forgive me if my examples are not focused on Mexico. However, our data do cover the world, and that's another talk. Next slide. So globally, we know that the emissions of the critical greenhouse gases reached an all-time high last year. Is there anyone in the room not in the front row who studies any biology, who's ever studied biology? Do you know what photosynthesis? Yes. So do you understand the idea of photosynthesis? How plants take carbon dioxide out of the atmosphere and put oxygen into the atmosphere. Every year, you'll see a squiggle. Where it goes down, that's the northern hemisphere summer absorption of carbon dioxide by the biosphere. The northern hemisphere, why do I say the northern hemisphere? That's where most of the land is, and that's where most of the land plants are, which is most of the primary productivity. Now, I just used a term that just means growth of plants. And so every year we see a dip in global carbon dioxide concentrations relative to the wintertime northern hemisphere high. But what's important here is that emissions on top of that are increasing carbon dioxide atmospheric concentrations year by year. So the biosphere can do some absorption of carbon dioxide, but if we keep adding 40% more carbon dioxide, we've added more than 40% in addition to historic pre-industrial carbon dioxide levels to our atmosphere. The biosphere can't keep up with that. Plants can't keep up with that. Methane. So methane is a byproduct of anaerobic respiration. And, microbes, small organisms produce this gas that is a very powerful greenhouse gas. The concentrations of this gas are much lower than this gas. So you'll see this says parts per million. This is parts per billion, but it's a very powerful gas, and it's increasing over time. Nitrous oxide is a very important precursor to a whole variety of processes in our atmosphere. I'm not going to get into all of that. The key is that we are increasing over time these inputs. Okay, that was a long explanation. Let's move on. And click one more time. Okay, so in the tropics, maybe you don't think about the word cryosphere very much. Has anyone heard this term cryosphere? C-R-Y-O, okay. C-R-Y-O, sphere. Ice on the planet is melting pretty much everywhere. So the Arctic, we call it an ice cap, but the floating ice on the ocean is melting year by year by year. The amount of ice in the Arctic Ocean is decreasing. Why should we care? As that ice melts, it opens up open water. Of course, that presents an opportunity for shipping. You can move across the northern hemisphere in the summer in a ship. But that is also an opportunity for the sun to heat water. If there is ice, the sun rays bounce off the ice, and it does not warm the planet. If there is open water, that water can absorb energy and become an emitter of energy, and that warms the planet in what we call a positive feedback cycle. The word positive might be confusing. It's a vicious cycle. You lose the ice because of warming, and the planet warms faster. So this is a big concern. Mountain glaciers worldwide have been declining my whole lifetime, and the Antarctic ice sheet is shrinking in volume and area. So this is one line of evidence. So if I only showed you this, some of you would be already convinced that global warming is happening. But this is just one piece of evidence. Let's keep going. I already showed you the gases, so that's two pieces of evidence. Next slide. So this is the global average temperature records from 4 different centers in the world. This is our space agency in the United States. This is the agency I work for, which is the Weather and Climate Agency. This is a research group in California and one in England. So what this reconstruction shows, there's different ways of calculating the global average temperature. Now, if you go back 100 years, our observations aren't as vast as they are today. So we have some variability in our estimates of what global temperature was 100 years ago. But universally, we understand that climate change is happening through observations. This is not models. This is not theory. This is just observations from stations with thermometers. Next slide. I think as people who live near the ocean, you're probably familiar with El Nino. Anyone not familiar with the idea of an El Nino? Okay, so the idea is in an El Nino year that the Pacific equatorial region gets warmer than average. And so the red and orange color here represents a difference from the average temperature over a long period of time, like the 20th century. And in this case, it's from 1985 to 1993 is the baseline, the average. So if it was an average temperature on a pixel, it would show up as white. And this is a phenomenon that cycles due to the circulation of the ocean. So we see warm years and cool years in the Pacific. Now, when you have a warm year, an El Nino year, on top of a warmer planet, you have a very warm year, and last year was the warmest year on record. That's what happens in an El Nino year typically. When the ocean over a very large space is very warm, it warms the surface temperature, and so the average temperature of the planet goes up. But what we're seeing is even in the cool years, a La Nina year, the planet is still warmer than it was historically. So just keep that in mind. There's variability in the climate system, and that's part of climate science. It's part of what we study and are passionate about understanding, because we need to know how variations in the climate system, in the ocean and atmosphere, which are coupled, produce different weather patterns on top of a globally warming world. That's our job at NOAA, is understanding those issues. That's another lecture that we could save for another day. Next slide. So, ocean heat waves, I think, are pretty close to your heart. I think you know that last year you experienced a very severe ocean heat wave event, and it affected the tourism industry here with bleaching event throughout the Caribbean. So what this map is showing is the number of months from 0 to 12 where the average temperature for each pixel on this map was warmer than average. And what is showing is a pretty big heat wave throughout the Caribbean and Gulf, in the Eastern Atlantic, and many regions of the world. So the warming of the ocean is a manifestation, one more line of evidence about the whole planetary system warming up. So please notice, I'm not talking about one thing that's changing. I'm talking about the ice, the atmosphere, the ocean, the whole planet. This is without even talking about biology. Yesterday we talked a good bit about biology, but all of this affects life on Earth. Next slide. So this is a product that we develop at NOAA based on satellite observations, and what it's showing is chronic heat, not just at a time and not over a whole year, but this is stress specifically focusing on coral reefs. And so the light blue areas, there are none. Oh, there's some near Tampa, Florida. There's no stressful water temperature there, probably due to fresh water coming from the land. Yellow color means this kind of an area would be a place we'd want to watch for coral reef stress. A warning means, okay, there's been some chronic heat, and that could be creating stress for organisms. Now, alert levels deal with the possibility of die-off, not just of one coral species, but multiple coral species. Corals are symbiotic with, there's two organisms. And so when there's the loss of one of those organisms due to heat, the coral won't survive. It can't get energy because of the loss of that organism. And that's what a bleaching event is. So we have data that help observe and predict when that stress is going to happen so that we can anticipate. So this is one of the tools that we have. You know, humans are tool users, right? We adapt by using tools. Now we have eyes and ways of perceiving the world through satellites, through buoys, through computer science and sharing data. That's part of our cognitive ability now, is to understand planet processes and use that information for adaptation. Next slide. It's important situational awareness. From shifting from the marine environment to the terrestrial, where we live, this map is showing the frequency of very humid, hot days. So you all know the difference between a hot, humid day and a hot, dry day. If you're in the Sonoran Desert and it's 100 degrees, it doesn't feel nearly as hot as 100 degrees by the ocean if there's no breeze and it's humid. It's that humidity that's preventing your body from evaporating water out of the skin and cooling. So we are very keenly interested in mapping humidity and heat together at NOAA. And what this is showing is that worldwide, there are population centers, very high population centers, that are experiencing extreme heat with humidity, not only where we are, but in areas with extremely high population. So that means our fellow humanity, the people we are related to, are suffering. And in a changing climate, will suffer more if we do not stop the effects of climate change. Next slide. We are very invested in the idea of drought at NOAA. And so we map the severity of drought, which we can measure in many ways. It would be a whole lecture just to talk about what does drought mean. It could be ecological, it could be hydrological, but this is looking at atmospheric moisture as measured from temperature records and precipitable water. And so we want to track drought severity to help people adapt. Next slide, please. I mentioned Arctic ice. When I started my career 25 years ago, I was showing people visualizations of Arctic ice where we had most of the Arctic Ocean covered in very old ice, which is depicted here in white, ice that's 4 or more years old. Literally in my lifetime, the minimum ice coverage in the Arctic, which used to have very old ice over the whole Arctic, is retreating massively, such that that ice cap is no longer providing us that albedo protection that I described. Next slide. So where is the climate going? Let's go to the next slide. At NOAA, we invest a lot of time and energy into modeling the climate system. So the climate models are one of the greatest achievements that humans have produced in the world. I better be careful getting near the speaker, sorry. I'm very lucky that didn't feedback. Climate models are a singularly fantastic achievement of the human species. They incorporate observations and theory and physics and code and computer science to generate an understanding of how the climate system could evolve. And so we study it from multiple points of view. We need to understand the constituents of the atmosphere. I'm not going to go into this deeply, but we need to model those because they have effects that we need to incorporate. We need to understand the variability of El Nino and La Nina, for example, and study how those events might change in the future. We need to be able to understand how a global warming would play out for different regions of the world and develop predictions. Projections is what we call them. One of the capabilities that you're very interested in is hurricanes. How can we predict and understand the evolution of tropical cyclones? Mesoscale dynamics is a fancy way of saying if the ocean and atmosphere are tightly coupled and you have an ocean heat wave, what happens to the weather right there? So we have to be able to model that. Take an event like a heat wave and then run a very complex weather model, a very high resolution to look at what that would do to you, to your heat stress, to your humidity, to the heat, and understanding impacts on the ocean. So all of these are massive domains of climate science. I can't touch them all today. But there are so many careers and opportunities, not just in science, but in communicating this and helping people understand the impacts on their industry, on fishing, on every business. So I better accelerate so I can get to some of that. Next slide. And we'll play this video. This is an animation of year by year. Thank you, Therese. Year by year, average temperature, where blues represent cooler than average for a pixel, yellows and reds represent warmer than average, and what you're seeing is playing out the climate system using this coupled ocean atmosphere model through time with a forcing of greenhouse gases. What you're seeing is we understand that there is not a single model on the planet that predicts the Earth will cool this century. There's not a credible model out there. Every model, even the most optimistic scenario politically, we're going to see a warmer planet. We must adapt and understand this. Next slide. So, next slide. You're not going to be able to read this slide. Don't read the text yet. What I want you to focus on here is that we're looking at gigatons of carbon dioxide on the y-axis and time on the x-axis, starting today and going out just about 25 years. If you focus on that, the message of this is that we need to get to net zero, and in order to do that, there's things that have to happen immediately, not next year, today. Next slide. The things that have to happen right now that aren't happening fast enough. Next, click, and you can just click every couple seconds. No new oil and gas exploration, no new coal plants, it should say plants, no new fossil fuel boilers in buildings, phase out all coal. China uses a lot of coal. The United States has been the greatest emitter of greenhouse gases in the world. We carry most of the burden of that. The EU and China also contribute huge amounts. We have to phase out all of these things. Keep clicking until you can't on this slide. Okay, so all of those have to happen immediately, and they're not happening fast enough. There's plenty of work for everyone in this building just right on that slide. Let's go to the next. 2030 is very soon. So in the next decade, phase out coal entirely, and we need to triple the amount of solar and wind on the planet, triple. Next, we need heavy industry to shift from fossil fuels to renewables. That's not easy. There are a lot of jobs in engineering and management and science to be had. We need to get all cars electrified. get rid of internal combustion engines. These are things that have to happen to get to net zero. I'm not talking theoretical. Heavy trucks also have to become electrified. Buildings must be carbon neutral, meaning our heating and cooling needs to come from heat pumps that are electrified, that come from renewable energies. Everyone on our planet wants a better quality of life. How are we going to do that? How are we going to provide for people who don't have energy access? Is there one more? Energy production systems themselves need to be net zero. And every appliance that you have in your home in the future, next decade, must be carbon neutral. Next slide. So, how do we implement all of this? I'll go a little faster. Next slide. What we have in NOAA is something called the Steps to Resilience, which focuses on taking today's condition where we have flooding, heat stress, asthma, and drought, and create a world that's electrified roads and transportation, where people can enjoy the outdoors, and where we have abundant fresh water. Next slide. So right now, this is literally what's happening where I live, in Asheville, North Carolina, on the other end of the hurricane we just experienced here. I live in Asheville, North Carolina, and this is what it looks like. Next slide. If we have appropriate drainage systems and electrical charging stations, we can have better quality of life. So addressing climate change isn't some doomsday, it's let's make a better world. Next slide. And just go through these quickly, Therese, please. Deal with heat stress by giving people ways of having outdoor environments that are safe. Just click, click. Giving you a pictorial representation of how we can make the world better through this work. Next slide. And next slide. And next slide. Next slide. So the framework I work on every day is called the Steps to Resilience. It's a risk framework that at the center focuses on lifting all people's lives and improving together our quality of life, beginning by understanding our exposure to climate-related stressors, assessing vulnerability and risk, dealing with options and plans that take the highest risk concerns and address those first. Next slide. So these steps, it's called risk assessment and risk management. So to get started, next slide, we have a series of steps that I've published in a book that you're welcome to use, but we're not going to go through every step. I'll just touch on a few things. Next slide. So understanding community history, click, next slide, is very important because in my country, our financial system has actually literally historically put some neighborhoods at more risk than others due to the color of people's skin who live there. And that kind of racism and economic disparity has been embedded in our financial systems and our political systems, and we have to remove that and help people live better lives. So first we have to identify the problem. Next slide. Hear people's lived experience. Next slide. And use that lived experience to learn what to do better. Next slide. So understanding exposure, next slide, involves now assessing assets as well as impacts. Next slide. And so assets, next slide, are things that we care about, people that we care about. Hazards are the climate-related events that can impact those assets. Next slide. Non-climate stressors are things like population growth and building in harm's way. Climate stressors, next slide, are things like that come from climate change. More intense precipitation, rising seas, increased temperature. These amplify those hazards that we were talking about. Next slide. And if you can play that video, this is the formation of the low pressure center of Hurricane Helene, and it's an amazing demonstration of our capability to see, to understand in real time these hazards evolving. And since you live here, you have a deep appreciation of when you see that, what you're going to do to prepare. And that's what we need to do across all climate hazards. Next slide. So we have here the history of every tropical cyclone going back more than 100 years that's passed within 60 nautical miles of where I'm staying while I'm visiting you. And that historical information is a critical part of, before we adapt, we need to know what we're dealing with. What's important to know is that with climate change, that our observations and our models both agree that a warmer ocean is intensifying these tropical cyclone events. And so for you, I believe it was Wilma in 2005, that was really the most devastating in people's memory. And being able to have situational awareness is something our species uniquely has right now. So we have some tools to work with. We have some capabilities. We're not hopeless. We're very ingenious, actually. And so you will have to figure out how to use these tools. Next slide. Including the climate history and the projections. In my country, we have climate data that we've summarized state by state. You probably have this in Mexico. Next slide. We have whole websites dedicated to combining social risk and climate exposure. We have our emergency management agency break this down into very small areas, units of 20,000 people all over the country where we can map risk. Next slide. We have, so this is showing a way to drill in spatially to that data. Mexico can easily do this. Next slide. We have data that show what are the impacts of sea level rise, pixel by pixel around our whole nation. Next slide. We have tools that look at the impacts of wildfire, which is a massive problem in the western United States. In fact, wildfire is such a big problem that the people addressing it aren't even interested in climate change. It's just right now absorbing all their time, money, and attention just to deal with the fires that are happening that would accelerate in the future. Next slide. So we have tools devoted to these things. We have a site that focuses on human health and the impacts of heat. Why am I saying this? There are professions, there are people, there are opportunities for helping people in communities around the country to adapt to all of these different climate-related hazards and help your community. Next slide. I personally work on getting people better access to the climate projections. So our climate mapping for resilience and adaptation is a tool that gives you access to what the global climate scientists use, but understanding what in your county in the United States, if you live there, might experience in the future. Next slide. And this is based on work that we did in a previous tool called Climate Explorer. These provide graphics and data that you can bring to your, in my country, the city council, the local state government, to help move action forward and show we have impacts we need to address. So climate projections are a big part of what I focus on personally. Next slide. And my main website that I help manage is the U.S. Climate Resilience Toolkit. You're welcome to take a look at it. Let's move on to the next slide. It brings together stories, people's lived experience, data, the actual observations and projections, what we know is happening in the climate system, plans, examples of people doing something, so that you can envision, imagine what to do where you live. That's what the toolkit is for. Quickly, let's click through a few slides, and you can just spend 3 seconds on each of the next couple of slides. We have GIS that we use to map neighborhood by neighborhood, parcel by parcel, building to building. We can use spatial data to understand what we're trying to protect, quantitative data on periodicity of flooding, heat events, qualitative data, what interviews tell us about people's lived experience. Next slide. So that we can gather an understanding of exposure and then quantify vulnerability and risk. Quickly, next slide. This step is important because it helps us differentiate why should we address surface flooding versus coastal flooding. So next slide. We can map sensitivity, click, adaptive capacity, click vulnerability. So vulnerability is a combination of what's at risk and whether it has some built-in protection. And that vulnerability score helps us prioritize the properties, in this case I mean a parcel of land, where there's a lot at stake. Whereas some parcels are less exposed, vulnerable, and at risk. Next slide. With risk, we break it down into probability, the period of return. So an event for you, a hurricane is every year or two you're going to have a hurricane. Next slide. The magnitude of impact is the severity of that event. And finally, the risk is a combination of the probability and the magnitude of that impact. So we can map these data. That is a significant opportunity to prepare. Next slide. And then we combine the vulnerability and risk to prioritize, well, where should we focus our adaptation actions? I'm showing an example that looks at property, but we can do this with qualitative data and social systems too. Next slide. That prioritization then tells us, well, what should we adapt to? What options should we consider? Next slide. Different professions are all taking this kind of information and interpreting it from their own perspective. And so I thought I might have in the audience some people who deal with coastal development. That may not be the case, but quickly, this is from architects, the Resilience Design Toolkit, taking the principles I just explained, next slide, and building beyond present day codes. So code, does anyone know what building codes are? No. Code is literally the worst building you can build legally is building to code. So if you build to code, you're essentially doing what the law requires. And what architects are saying is, well, let's, for our clients, give them something better that's resilient. Next slide. And so you can consider how a hotel that's near the ocean might position its resources. So elevating access for pedestrians, getting the critical infrastructure off of the base flood elevation. Next slide. Getting critical infrastructure out of the way. Mechanical equipment is not exposed to flooding, for example, in this design principle. Next slide. All the energy comes from renewable sources. Reduce the heat load of a building using green roofs. I guess I would recommend to my hotel, replace the windows. So designers can come up with ways to address the highest priority issues once they know what's most at risk. Next slide. And so we build in adaptation, which overall improves the quality of life. Next slide. So here's something to keep in mind though. You're in your 20s, and what you plan today is going to last for a certain amount of time. Next slide. But in the future, there's going to be more sea level rise, more flooding, for example. So you better have a plan for what's next. And next slide. And then what is after that? So there's a whole pathway for adaptation so that you're not putting in place something that is maladaptive that prevents your colleague 10 years from now from doing their job. So we have to think intergenerationally. Next slide. Across time. Next slide. And next slide. Next slide. Bottom line is this is going to be an ongoing adaptation process for you and every generation that follows. Next slide. I had a whole example for Broward County, Florida, but I want to respect the fact that we have other speakers, and I can offer to go through this or pause it. I have a whole example of how to design infrastructure. Okay, in Broward County, Florida, next slide, Jennifer Gerardo is a hydraulics engineer, a civil engineer, who I've known for more than a decade, and she's part of a multi-county effort to understand sea level rise impacts on municipal governments, local governments. And they've been at this for some time. Next slide. What they do is every 5 years, they will update what their design standard is based on the fact that sea level is rising. So they're moving from one standard now to a new standard based on higher expected average sea level. So they are thinking, as planners, as engineers, we must require buildings and new investments, especially if they're $1 billion or more, to deal with this problem. Next slide. And so they have maps that show, well, what are the areas in our county that have especially critical flooding risk due to this sea level rise. Next slide. This is very sophisticated, by the way, for a local government to have done this. So please appreciate that this is the leading thinkers in the United States. And very important here is they've modeled how sea level rise, sea level, shown in red, interacts with groundwater, shown in blue. So I know this is important to you. It affects your drainage systems, it affects your access to fresh water, and the salination of your fresh water. So they've mapped and projected what the impacts of sea level rise are on access to fresh water and drainage systems. They've also mapped where does surface water come above the ground today, creating development problems. So this is a transect across the county, this line, and where this brown line, this is the elevation of the land, where it goes below the water table, you have flooding all the time and no drainage. So the fact that they've mapped that and they understand where the risk is very important. Next slide. And they're able to then prioritize track by track and zone by zone in the city. The purple areas are the areas subject to sea level rise. Then they're able to look at, well, what is at risk? What infrastructure do we need to plan for? Next slide. And roads are one of those important pieces of infrastructure. And what this is showing is that I-95, a big highway, goes below the water table in some key places. And then if you add sea level rise on top of that, that risk is even greater. So now we're talking billions of dollars of infrastructure. Big decisions, next slide, that need to be made in Broward County. And so they've been building in this kind of advanced engineering, modeling, geophysics into city planning. Next slide. Let's move on. Next slide. What's important is that they have a modeling system that is done from a civil engineer's point of view. This is not a climate model. So whatever profession you go into, you might be using climate data and incorporating those data into something that addresses an infrastructure problem. And this is showing some of the concepts that go into the civil engineers planning for infrastructure. Next slide. And let's go to the next slide. Too much. But I wanted to point out that this is a real person. She's a pioneer. She's a thought leader, very highly respected in my country, and is someone we look to for leadership. The White House invites her to come and talk. How should we adapt? So that could be you. Next slide. And next slide. Next click. Next click. Next click. Next click. And maybe one more. So, we know what's at risk. We know what you're exposed to historically. But we also know that there's new challenges ahead of us. And we're going to have to work together across society to solve them. And if we're not climate literate, we're going to fail at preventing more problems in the future. The return on investment in climate adaptation is more than 6 to 1. So if you're just a finance person and you want to save money and make a good investment, you will do resilient infrastructure, building, design, service provision. Next slide. I think it came up yesterday quite often that we give the impression that young people, if they envision the world differently, but we don't give them opportunities to really build that world, we're creating a cognitive dissonance. We have to have a whole systems view of how to work at a political level, industrial level, commercial level, business level, education level. And so climate literacy is interwoven into your interactions in your career from now forward. And I hope you take that to heart. And whenever you need more information, know that there's a lot of free data from NOAA, but the international community of climate scientists, biodiversity scientists, want you to use their observations, their data, what they've learned in your own work. Next slide, and I thank you for your time.
Muchas gracias al doctor Ned Gardiner por su presentación y queremos ver si hay alguna pregunta que le quieran hacer al doctor. Está disponible en este momento. Ok.
Well, first of all, thank you for your presentation. And is there a way that, or is the NOAA planning to do some research or something about hurricanes and in this area? Or are they planning to, I don't know, to educate people as of things we can do to improve or, I don't know, a way of living or be more prepared or really taking this seriously?
I think through collaborations like this where we begin to build the bridges needed, but NOAA has a lot of science you can use right now in terms of climate modeling and hurricane modeling specifically, understanding the dynamics of how hurricanes evolve in a warmer ocean. In my lifetime, in my career, the ability to model and understand the warming waters of the Gulf of Mexico and their impact on landfalling hurricanes in the United States has been a huge advance. Also, NOAA has moved its weather forecasting into a computational environment that's more dynamic, that deals with ocean conditions as they change. Historically, we used a fixed ocean, and now, since the Europeans did a better job predicting Hurricane Sandy, I don't know if you remember that, but it was a big deal in the United States. We had a post-tropical cyclone system come and slam into the mid-Atlantic coast of the continental United States. And so we are evolving how we do weather prediction as well as climate modeling, and those data are all available freely. So short answer is no, there's not a specific mandate in NOAA to help Mexico adapt and understand. But yes, the data are available and our scientists want to help you to do your work. So I do believe there will be opportunities to certainly use the data at minimum. And we could continue that conversation by email. There's my email address. Thank you for the question.
¿Alguna otra pregunta?
Gracias, doctor. Excelente ponencia. Me gustaría comentar un poquito de lo importante que es la información que nos dio. Yo trabajo para el gobierno federal en la elaboración de opiniones técnicas, dictámenes que tienen que ver con obras y actividades en la zona costera. Entonces, nada más para que se den una idea, hasta hace un año más o menos, nuestra tarea de opiniones técnicas al año era de 30, más o menos. Ahorita, al mes de mayo, ya llevábamos 42, 43, entonces eso nos da una idea de la presión de crecimiento costero que hay en el estado. Entonces, toda la información que usted nos ha dado nos sirve mucho porque los desarrolladores, los municipios, como que nadie se toma en serio el cambio climático. Sin embargo, todos estos datos nos van a servir para intentar meterlos un poquito en lo que son esas opiniones técnicas para ver el riesgo y la vulnerabilidad de toda la zona costera. Y estoy hablando de todos los municipios, desde Isla Mujeres, Cancún, la zona intermedia, hasta la zona sur, Bacalar y Chetumal, que ya de por sí tiene situaciones de riesgo altas, ¿no? Entonces, muchas gracias y de verdad vamos a recurrir a toda esa información. Gracias.
And if I could follow up briefly, the federal government in the United States doesn't have the capacity to answer every question of every municipality. So I design and manage programs that bring resources to municipalities to do the work, and they can apply and get funds. So there's a lot we could talk about. There's so many different programs, but that's an area where I do a lot of work on a policy level. Also, for the younger people, there are business opportunities to support that work, consulting. I have been working with the private consultants who understand climate change is real and understand how to do the mapping I was showing you to support the capacity of local government that doesn't necessarily have on staff the people to do it, so that you as a federal representative can bring a broad perspective and resources to support local adaptation. And that's a strategy that I'm spending most of my days on. Thank you for your comment.
Bueno, yo voy a hablar en español, si no te importa, para la mayor parte de la gente. Nos has dado una plática súper interesante de todo el potencial de la NOAA y de su potencial sobre todo para hacer modelos y modelos predictivos. Lo que yo querría también conocer de ti es dónde están los agujeros, dónde están las debilidades que todavía se tienen que resolver para ser más efectivos a la hora no solo de dar a conocer la problemática y decir, oigan, está pasando algo o se prevé algo súper grave en los próximos años, sino para poder empezar ya a poner soluciones sobre la mesa en el planeta, vaya.
25 years ago, when I started taking seriously the need to help other people understand climate change, I thought differently than I do today. I thought, I will provide the information and they will do something different. It took me 5 years to realize that even if I translate the story and show, I was showing videos before people arrived of things I've documented 10 years ago even, that's not enough. And then 10 years ago, I shifted to focusing on how to build a framework for decision making. That's not enough. Even if I'm talking the language that in your profession you understand, you're not necessarily going to use the data. So now I have to go further. Now I have to find the person who has an economic interest to make a case to someone else that they should hire them. In my country, capitalism is what rules. So we have to have the impetus be self-interested. And so what I have committed myself to is always learning to keep moving to where the people are and try to understand what it's going to take to help them use the information. So the gap is that we can't just provide information. We can't just show people for their own self-interest why it's enough. We can't just rely on their value systems. We actually have to show up in their living room somehow. And that won't be me. As a federal person, I can't be everywhere. So I have to find colleagues. And so I'm building programs. That's what I do in my job. to help other people be in the living room, be in the city council chamber, and be in the CEO's office, making the case. The CEO is not going to learn about climate change and become the advocate. They may support it, though, if they see their interest. And so we have to cultivate a new workforce. So one of my programs is Climate Ready Workforce. And what I have found is that even when I write on the requirements of a federal grant application, you must say this about how you're addressing climate change, still people can't do it because they're not literate yet. So we have to do all these things together, climate literacy, provide new opportunities for business, new opportunities for better livelihood, address social issues. It's a whole systems perspective, which is why when you see a group of people in their 20s who are thinking about what to do in their career, there are so many opportunities with their sophisticated skills with social media and with understanding how fast the world is changing, but we have to connect intergenerationally. That's a huge gap. Even in my household, so difficult to get the device out of the way of communication. You know, to get each other's attention. You know, in indigenous cultures, there's this circle. You sit in the circle and you listen and you share. So that, I think, is our biggest gap as a species. I get calls from parents sometimes. My child wants to know what to do about climate change, and what are you worried about the most? And I know, I've given this answer before, and I know they're disappointed. They want to know some technology that's going to change it. And my answer has always been, because it's been proven time and again, what I'm most concerned about is that we don't learn to speak to one another. I can't even speak Spanish. That's on me. I haven't done that work. So what I would like to give to you as the opportunity is finding ways to connect across generations and cultures is very important. And climate science is a culture. Even, you know, when I meet climate scientists, we have a shared understanding of the world that we don't have to explain. But we do have to explain when we go to another culture, even if it's our neighbor. Does it make sense?
Yes, the problem is that they are victims too. The future they are receiving is terrible, and they don't know it yet.
Victims, and they have the opportunity to prevent future. You know, I hear a lot of victimhood from young people, like the world is going to end or be destroyed. No, actually, it's worse than that. Humans are very adaptable, and the world can get harder, and we will adapt. That's the problem. We will adapt. We must prevent the worst things from happening. We must find a way to communicate this message, that it's urgent now. Because we must do this work. And if we fail, then yes, they're inheriting something bad. But that's on all of us. That's not on you alone, and it's not on her alone. We all share in that responsibility together, I think.
Well, first, thank you very much. I will ask my question in Spanish, but first I want to thank you because I've been in a lot of climate change conference, and I think the information, the data was pretty good and very easy to understand. So thank you for that. And also, I think it's kind of funny that after all this science and data you show us, at the end is communication and social skills, right? It's an interesting conclusion. So my question in Spanish. Por lo que entendí, sobre todo como este toolkit de resiliencia y todo este plan y en general como durante la exposición, en mi percepción fue algo como muy antropocéntrico, ¿no? Como muy centrado en la adaptación a la humanidad, cosa que entiendo en parte porque pues estamos en riesgo. Y también entiendo que es porque nosotros como humanidad hemos llevado el cambio climático a estos niveles, pero siento que queda como un poco relegada también como el bienestar de todos los seres en este planeta. Entonces no sé si eso es por un tema científico constreñido o simplemente una visión cultural.
Okay, I'm applauding in my heart for the comment. I'm a biodiversity scientist first. My training is, if you reach into a river where I live, you will pull 8 species of minnows, and it's incredible. You're witnessing the culmination of millions of years of adaptation. Post-glaciation, these fishes came up into these headwater streams and adapted to the world they inherited. And we must learn from them. I cannot go into a room like this and start there. If I start there, I've lost them already. Well, I've already lost them. But yes, my values are aligned with your values, and we must protect the mangroves. We should retreat from the shoreline and allow natural processes to evolve and let the sand move and let the silt come in and let the rivers flow. That's the end conclusion. That is the conclusion. And will you go back one slide, please? That's why the image that you saw at the end wasn't of monolithic concrete structures and zombies walking in the street. It's a world where we have mountains and rivers and biodiversity, and where we coexist. Yeah. Where we've adapted to the landscape, and we are in the landscape.
Sure.
Muchas gracias, Ned. De verdad, agradecemos tu...